Hello and welcome to this beginner's guide to first, second and third normal form when looking at database normalization. So let's get started. First normal form. This one is nice and simple. All rows must be unique and all cells must contain atomic values. Well, what does that mean? Well, it's really quite simple. Each row in the table must be unique, and therefore there cannot be any duplicate rows in the table. So you can't have two different rows where all of the data contained within those rows is identical. And we'll give you an example in a minute. And each cell must only contain a single value. So you can't have a cell in a table that has a list of values in that cell. That's a no-no. And finally, each value should be non-divisible, which means that if you've got something in a cell, you can't break that down into further sensible parts. So let's have a look at an example of each of those. So each row must be unique. So let's have a look here. We've got a table of takeaway orders here, and we've got for each takeaway order, we've got a customer name and a customer order. So, for instance, Bob Jones ordered here. He ordered burger, fries, and Coke. Fred ordered nuggets, lemonade, and fries. And then Bob also ordered burger, fries, and Coke. Now that's fine, apart from we can't tell the difference between this row here and this row here. So we have no idea, for instance, which order was ordered first. We've got no idea at all. So we need to change that because they need to be uniquely identifiable. And the way we do that, nice and simple, is we just add an order ID column. So here, order ID number 1, well that was Bob Jones, and he ordered his favourites there. Order ID 2 was Fred's, and he ordered all those. And then the final order was Bob Jones, and he ordered his favourite order again there. So because we got these order ID, that row there is now no longer identical to that row there. There we go, good. So that's the first part of first normal form done. Second part, let's have a look. Each cell must only contain a single value. Well, yep, as you can see here, this cell here doesn't contain a single value. It contains 3 items, a burger, fries, and Coke. In fact, all of them do. So these ones here, in this area, the actual order ID, they all do. So that's no good. So what we need to do there is we need to move those into a separate table so that each row only has 1 item. Let's have a look. So it's going to look a bit like that. This table here has an order ID in one column and the item corresponding to that order ID there. So order ID 1 has a burger, order ID 1 also has fries, and order ID 1 also has a Coke in there. And as you can see, each item in this table now is unique, and there's no multiple values per cell here. So that's sorted now. So that's the second bit. Good. Third thing, all data must be atomic or non-divisible. Well, what's the problem? Well, if you have a look over here at customer name, Bob Jones, you can actually see that Bob Jones isn't atomic. It can be divided further into into his first name and last name, and that's no good. Okay, because that makes it some kind of composite value. That's no good. It needs to be separated out because those are different things, and it looks just like that. So you create a column for their first name, a column for their last name, and you just put them in separate cells. It looks like that. Good. So that's how you put a database table into first normal form. So now let's move on to second normal form. Now, second normal form, not quite as much to it. All you need is there are no partial dependencies. Well, what does that mean? Well, what it means is, first of all, that the table must first be in first normal form. So you can't have a table that's in second normal form until you've gone through all those rules that we just did from the previous one, from first normal form. It must do those first, and then we must have all non-prime attributes should be fully dependent on the candidate key, and it's fully dependent on the whole candidate key. Well, what does that mean? It sounds a bit complicated, but it's not. So let's have a look here. We've got a list here of students so the student ID, the course ID that student is doing, and how much that course costs. So here, this student, they're doing course, so student 1 is doing course ID number 1, and that course costs 500. And student, so student ID 2 here, he's doing course 3, and it's 750, and student 3 is, student 2 is doing course 3, and here student 3 is also doing course 3, and it's costing 750. Well, what's the problem with this table? And the problem is that the course fee has got nothing to do with the student ID. So the course fee is a set fee that only depends on the course ID. So this particular course, course 1, costs 500. Course 2 costs 1,000. Course 3 costs 750. And as you can see here, it doesn't matter whether it's student ID, student 2 is doing course 3 or student 3 is doing course 3. For either of those students, it costs 750 for each. And that's because the course fee has nothing to do with the student ID. Now, it's important here to note that the course fee is not dependent on the student ID, and the student ID forms part of this composite key here of student ID and course ID. So this is the composite key, but this bit is only dependent on that bit, and it's not dependent on that bit. And that's where you get this partial bit, because it's not dependent. It is dependent on this part of the composite key, but it's not dependent on this part of the composite key. So that's where we get the partial part of it. So what have we got to do to fix this? Well, nice and simple. All we do is we move this information to a separate table, just like that. So we have a table about course fees, and each course ID has a course fee attached to it. Course 1 is 500, course 2 is 1,000, etc. And the other table we pretty much keep the same. But we don't need this extra course fee information. We just get rid of that column, and we only have the student ID and the corresponding course ID. So student 1 is doing course 1, student 1 is also doing course 2, student 2 is doing course 1 and course 3, etc., etc. So that is no partial dependency. It must be fully dependent on each of these parts of the composite key, if you've got one. Okay, so that's second normal form. Third normal form, no transitive dependency. So it's similar to the previous one, but we're not talking this time about the primary key or the composite key. We're talking about something else. So, just like when you tried to put something into second normal form, it had to already be in first normal form. Well, third normal form is the same idea. What you need to do is it needs to be in second normal form. But of course, that also means that therefore, if it needs to be in second normal form, it must also be in first normal form, because the two go back. So anything that's in third's got to be in second, and obviously anything that's in second's already got to be in first. So it needs to tick all those other boxes. It can't be duplicates, it can't be divisible, it can't be multiple values. It also can't have a partial dependency. So all of those, and then it must also do this third, this other item here, which is no transitive dependency. Again, sounds a bit weird, but all it means is that all fields must be only determinable by the primary or composite key, and you can't determine any of the fields by other keys in there. So what does that mean? Well, let me show you a nice simple example. Here we go. So here we've got a list of tournaments that I've pulled from Wikipedia, and here it's there's the tournament name, and that's the year the tournament was in, and then we've got the winner of the tournament and the winner's date of birth. So this works well. It all fits through to first and second normal form, but there is a problem with this table, and the problem is that you can determine one of these keys by looking at another one of those keys. Can you see which one it is? Well, nice and simple. It's here. You can tell what the winner's date of birth is by going to the winner's name. So here you can go. You know that the winner's date of birth is this date of birth because that's his name. Okay, and he's got that name. So although it's not dependent on these bits here, you can't tell the winner's date of birth from the tournament name or the year, you can tell the winner's date of birth from the winner's name. Okay, so that's no good. So this information, as it stands, can't sit inside of the table. So what have we got to do? We've got to fix that. And you could do that by having a separate table of winners here. So for instance here, we've got the tournament name, the year, and the winner there. And we have a separate table that says, okay, Al Fredrickson, his date of birth is this. And we split the two. And this works because here the winner is dependent on the tournament name and the year, because that tournament happens every year. So you can't work out who the winner is just by the name of the tournament itself. And there are multiple tournaments in one year, which means you can't determine the winner just by looking at the year. You have to use both of the name of the tournament and the year in which it was held in order to work out who the winner is. So that fits perfectly. And then over here, again, the date of birth corresponds to that particular winner. There you go. Okay, good. So that is first, second, and third normal form. If you like that, then please subscribe to my channel. If you've got any comments or any suggestions for other videos, then please just drop me a comment. And good luck. Thank you very much.